My name is A.L. Goldman. I teach physics at El Camino College. To begin our study of wave motion, I'm going to demonstrate for you a fairly simple kind of wave, which is a wave propagating on a stretched spring. You can see that I have a long spring here, and I'm holding one end fixed, and the other end of the spring is fixed to the pole at the other end of the room. At the moment, the spring is in equilibrium, and as long as I don't move, and as long as the pole at the other end of the room doesn't move, the spring will retain its equilibrium. But now, let's say I disturb the equilibrium in this portion of the spring, which is right next to me. You can see that the disturbance I created to the equilibrium of the spring next to me did not remain next to me. Rather, that disturbance, once created, propagated back and forth along the spring. Now, how was that disturbance able to propagate along the spring? Well, when I first created that disturbance, I had a little bump in the shape of the spring like this. You can see that this end of the disturbance over here is able to pull down on the next region. So now I have a disturbance over here. Then this end of the disturbance is able to pull down on the next region over here, and so forth. In fact, all kinds of waves function on essentially the same principle. In any sort of wave, we start with the medium in equilibrium and somehow disturb the equilibrium in one region of the medium. Then, once we have created that initial disturbance, that disturbance creates a like disturbance in the next region, which then creates a like disturbance in the next region, which then creates a like disturbance in the next region, and so forth. So, once you have created that initial disturbance, that disturbance can propagate through the medium as a wave. Thank you for watching.